Hello everyone, I'm Shreya and I welcome you back in this machine learning tutorial series. So, as we already discussed in the previous video that we choose the best fit line depending on the value of that is the difference of that is y naught minus yp, where y naught is actually the actual output that a data have, and the summation of all those the difference between y naught and yp whole square and summation of those all those data sets is basically used to decide the best fit line. And so as I have already shared the today's ppt, that is that the ppts that I'm going to discuss in the previous video also, you may have saw that how we are choosing the best fit line. So I'm explaining the ppts uh, here also. So as I have already discussed that this is the main main uh, thing depending on which we like choose the best fit line. So here I have an example. So for the for the same case study, that is for the case study on the GRE and the GPA scores. And for there we have like different best fit line, that is we have chosen this as the one of the best fit line, and this is one of the best fit line, and this is one of the best fit line. As I have already discussed that we can choose any of the lines. So here if we try to find out the values of this one, that is y naught minus yp whole square summation, then in this case we get 28 as the value, and here in this case 22, and here in this case 24. As I have already discussed in the previous video also, that residual, that is the difference between the that is the actual value and the predicted value, that is the residual must be lesser, like must be small, so that we can have the result closer to the actual result. So we are choosing our best fit as this only, that is best fit line here. Now moving forward, here the measure of good fit, as I have already discussed that for the linear regression we have the equation as y is equal to a plus bx, right? So here we try to plot the we will try to find the different parameters, the actual value. Okay, so for this case we have like a values as 261 and y value as the GRE score, as we are GRE score is dependent on the CGPA, and x as the CGPA, and we have the v value as the 6.8. That is basically a slope, whatever we have studied in the tangent, in the trigonometry part of our syllabus. And there we saw that how we try to find out like a upon v, which is basically the measure of the slope of the line. So from there from that basic logic, we have find out the values of 260, as a as the 261 and b as the 6.8, and from there we try to find out the GRE score on like CGPA of 8.32. Then the expected GRE score for 8.32 CGPA student is 317.57. So moving forward, as we have already discussed that we are mainly focused to the simple linear regression, but linear regressions are divided basically in three types, that is multiple regressions, simple regression, and polynomial regression. So as we have already discussed simple regression, so now I will discuss about multiple regressions. So I'm talking about the multiple regression. So Multiple regression is what, like in this we have one dependent variables and more than one independent variable. As you can see, we have one dependent variable that is dependent on different independent variable, that is x1, x2 and xn. This is the basic structure of the multiple linear regressions. Talking about polynomial regression, polynomial, as the name suggests, it will depend on the nth power, like of the independent variables, like x1 square, like in that way. So we are not going to discuss about polynomial regression and multiple regressions in detail, uh, but we have discussed simple linear regressions in detail. Um, so that was our basic focus of linear regressions, and in the in upcoming videos we will discuss about different demo of linear regressions. So that's all. Hope you liked it, and stay blessed.